Last time, we studied about the two special right triangles. Do you remember? We now extend the definitions of the basic trigonometric functions beyond triangles so that we consider acute angles, obtuse angles, and angles exceeding 180 degrees, or even to negative angles. In geometry, we think of an angle as a union of two rays with a common vertex. The beginning position of the ray, the initial side, is rotated about its endpoint, called the vertex. The final position is called the terminal side. The measure of an angle is a number that describes the amount of rotation from the initial side to the terminal side of the angle. Positive angles are generated by counterclockwise rotations, and negative angles are generated by clockwise rotations. We usually place an angle in standard position in the coordinate plane, with the vertex of the angle at the origin and its initial side lying along the positive x-axis. Two angles in this expanded angle measurement system can have the same initial side and the same terminal side, yet have different measures. We call such angles coterminal angles. Positive coterminal angles are generated by counterclockwise, and negative coterminal angles are generated by clockwise rotations. For example, angles of 90 degrees, 450 degrees, and negative 270 degrees are all coterminal angles. Because 450 degrees equals 90 degrees plus 360 degree, and negative 270 degrees equals 90 degrees minus 360 degrees. There are angles of pi, 3 pi, and negative 99 pi radians. They are all coterminal angles. Because 3 pi equals pi plus 2 pi, and negative 99 pi equals pi minus 100 pi. That is pi minus 2 pi times 50. In fact, angles are coterminal whenever they differ by an integer multiple of 360 degrees or by an integer multiple of 2 pi radian. Let theta be any angle in standard position and let p, x, y, be any point on the terminal side of the angle, except the origin. Let r denote the distance from p, x, y, to the origin. That is, let r equals square root of x squared plus y squared. Then sine theta equals y over r. Cosine theta equals x over r. Tangent theta equals y over x. For example, there is an angle of negative 210 degrees. The reference angle is 30 degrees, so let's draw a right triangle. Using the x and y coordinates of point P, we have sine negative 210 degrees equals 1/2. Cosine negative 210 degrees equals negative square root of 3 over 2. Tangent negative 210 degrees equals 1 over negative square root of 3. Let's consider another example. Here, we have negative 270 degrees. Sine negative 270 degrees equals 1. Cosine negative 270 degrees equals 0. Tangent negative 270 degrees is undefined since the denominator is 0. See you next time.